I know that Shelley's going to give you a formal introduction, Dr. Héroux, but I wanted to thank you on behalf of C4ST and all our volunteers across the country, and also congratulate you on your recent paper publication, one of many, 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 but this most recently, the collision between wireless and biology. So I know you'll probably reference that in your discussion, but I'm looking forward to it. And again, thank you. I know you're a very busy man, and appreciate you volunteering to spend the time with us on this very interesting and challenging topic. And now I'll turn it over to the official moderator, Shelley, who does a great job of organizing all of these great speakers for us and running these sessions. So thanks again, Paul, and Shelley, over to you.
Thank you, Frank. Dr. Paul Héroux is a scientist with experience in physics. His credentials include BSc, MSc, and PhD, engineering for 15 years, and the health sciences for 38 years. He started his research career at Institut de Recherche d'Hydro-Québec in Varennes, Quebec, an internationally respected electrotechnical laboratory. He repeatedly acted as a consultant to the telecommunications industry. After expanding his expertise with courses in biology and medicine, Dr. Héroux developed a keen interest in public health and was appointed associate professor at McGill University's Faculty of Medicine. He is currently the vice chair of the International Commission on the Biological Effects of Electromagnetic Fields, ICBE-EMF.org. His area of expertise are the health effects of the electromagnetism and environmental toxicology. Thank you, Dr. Héroux, for sharing your internationally acclaimed work with our Canadians for Safe Technology members and guests. We are truly interested in the biological effects of electromagnetic fields, including your article, The Collision Between Wireless and Biology, and your presentation today on the abuse of science. We look forward to your presentation.
Okay, so I'm going to talk to you about the article Collision Between Biology and Wireless, but since I am an old man, I thought I would start by sharing a few experiences with you at the beginning of this presentation. But the title of the presentation is Science Abused. What it means is that it seems that science is the only thing that we can trust with our experience with politicians. But science, there's many scientists, and there's a multitude of people who call on science to support their own opinions. So it's hard to know who to trust. Many people talk for scientists without the proper qualifications. So I will illustrate 4 instances in which science was influenced, it's not pushed aside in the interests of short-term commercial agendas. So the first one is from 1991. It's from a colleague physicist, Robert Adair. And so he published an article in which he claimed that, in fact, the health effects of weak electromagnetic fields were impossible. And I think he did this in a very devious way. And I am reporting this because I was in the audience when he presented this stuff. And so I want to show you the kind of sleight of hands that is done to mislead the public. So what he did in this article here is that he used a simple equation, E equals the field of the Earth multiplied by B, showing that a charge moving at speed B in a car or plane and in the Earth's magnetic field, B Earth, creates an electric field. So you note in this equation that the speed in a car or plane is more or less constant. And the field of the Earth is also constant. Consequently, the field E is a constant. So your car or plane does not move at 60 hertz. But in his article, he compared apples to oranges by matching the intensity of this DC field to the maximum field generated by a 4 microtesla AC magnetic field. So how could a trained physicist like Adair really forget momentarily the distinction between an AC field and a DC field. So this is very disturbing. So could the engineers in the audience, who were very happy with his conclusions, also have a lapse, a mental lapse, and not notice that the DC field is not an AC field? And you may think that this is trivial, but when you repeat these, I would say, these biases for a very long time, ultimately it has an impact on everything. So going to the second one, this is an event in 1994 with Benedict Armstrong. And it refers to an instrument that I designed to measure electric magnetic fields and pulsed electromagnetic fields in the utility environment. So we did this study between France, Ontario, and Quebec. And in 1994, Armstrong published a report in which he said that the pulsed electromagnetic fields were associated with lung cancer in utility workers. In the article, he said there was an association of pulsed electromagnetic fields with lung cancer that was strong by any standards. In other words, he was surprised at how obvious it was. So the reaction of the utility to this publication was very, very swift. They refused an extension of the project to investigate these cancers. All dosimeters were confiscated and all the data was erased. So following these publications, I was chosen by the McGill team to present the cancer findings to an IEEE committee chaired by Eleanor Adair called SC4. And as a result, IEEE formed a committee to investigate this connection between PEMF and cancer. So I was in the room where they were calling for 3 volunteers to form the committee to explore this question. And they wanted 3 volunteers. So I raised my hand, and seeing only one other hand in the room, I hoped that I would be part of the action. But in fact, as you might expect, I never got the call, and found later that this difficult question of lung cancers and PEMF had been handled by other people considered to be more sound. I had designed the instrument and was part of the epidemiological team. I had a unique position, but I was completely ignored. Is this a kind of filtration? Well, I think it is. Another event that I was a witness to is 1997 Henry Lai. Henry Lai reports here on magnetic field and DNA strand breaks. So this relates, of course, to the comet test. But essentially, Lai was reporting on something that I was prodigiously interested in, whether magnetic fields could produce effects on DNA. So the position of the utility was more or less that strand breaks should be impossible because the radiation is non-ionizing. At the time, I was a researcher at IREC, the research arm of the Quebec utility, and I was fortunate enough to be at this conference. So my boss, before I left for the conference, told me that the test that Lai performed was poor and was bad. But I knew that my boss in the utility had no knowledge of biology, so I didn't discuss this further. So after the conference, I went to see Henry Lai, expecting that he would be swamped with solicitations for more information. But when I got to Lai after his conference had finished, I realized I was alone with him in the room. And the explanation for this is that Lai had already been war-gamed by Motorola from earlier results on DNA damage associated with RF radiation. Lai had become a leper. In other words, he could present at conferences, but nobody would pay attention to him. So again, something very interesting to think about. So if you want to know about the documents from Motorola's corporate communications department, this is from Microwave News, they were adamant that they had to discredit him. And there's a statement here about exactly what they intended to do. And you have to know that they tried to have him fired from his job at the university for publishing these results. So their statement, internal statement, was, I think we have sufficiently wargamed the Psi-Link issue, assuming the Scientific Advisory Group, WTR, and Cellular Telecommunications Industry Association have done their homework. So there is truly an organized cabal to try to discredit the researchers that find positive results. Another event is in 2009 with Jerry Phillips. Now, he has at that point published a review of COMET test results. For those of you who don't know what the COMET test is, it is illustrated here. You have an intact nucleus here, and these nuclei have been increasingly damaged by a chemical here. And the longer the tail, the more damage there is. So this is very simple. It's very similar to what happens when you see parts falling out of an old car. The more parts are falling out, the higher the damage. So my boss had told me, as I mentioned before, that the COMET test was not a very good test. So at that conference where Phillips was present, and after his conference, I shared an elevator ride with him, and I simply told him, I hear the COMET test is not a very good test, saying that very naively. So Phillips just said, it is a very good test. And so this was the shortest scientific conversation ever. And what I like to convey here is that there is very little actual conversation between the two sides in this debate. It's mostly entrenched positions that are dug up to protect specific interests. Okay, so now about the deeper aspect of the health effects of electromagnetic radiation. I'm sure most of you are aware that we have here the thermal limit for electromagnetic radiation in microwatts per square meter, and that is about 10 million microwatts per square meter. This is the SC safety code 6 limit, as well as the FCC limits. But we have on the left here, at much lower level, the recommendations of the European Academy for Environmental Medicine for various categories, the Austrian Medical Association for various categories. We have as well the international guidelines on non-ionizing radiation and the building biology recommendations, which apparently all see the same thing. And what we have is a health to thermal protection gap. The thermal limits are here, the health limits are here. So this is, I guess, a little bit troubling. Now, the protection gap can be explained by a misuse of physics and ignoring biological knowledge. So this is more or less in the meat of the article about collision between wireless and biology. So what do the utilities and telecommunication companies tell us? They say that don't worry, because these radiations, either power or wireless, are non-ionizing. Then they say they're not thermal, they're too weak to do anything. And then they say there are no mechanisms to explain the health effects. So with these arguments, they very assuredly claim that there's no health effects from these radiations. Fortunately, that's not really true. So in this article that I published, The Collision Between Wireless and Biology, I aim to show that physics and very fundamental science, which are undeniable, are incompatible with the notion that wireless is inoffensive. So non-ionizing. Non-ionizing. So radiation is inoffensive because it is non-ionizing. This is a sophism or circular reasoning that limits thinking to a single variable, ionization, and is based on what we call the Arrhenius equation, or originally developed for gases, something very old, but that satisfies the thinking of industry. They say the energy for ionization is so large, while the energy from radio frequencies is small, and from power frequency radiation even smaller. Consequently, ionization is impossible. But the truth is that ionization is irrelevant in this context specifically the ability for the radiation to ionize anything. Now, they say it's too weak to heat tissues, and they take again the energy metric. They see the thermal energy of a water molecule is large, whereas the energy available from radio frequencies or extra low frequencies is very, very small. So one would assume that any effect of the radiation is overwhelmed by thermal energy. Very simple. But the radiation's energy is not applied to water or even to atomic ions. They identified the wrong targets. It is applied to electrons and protons that are free to move in living tissues. And we'll see below that these free electrons and protons are required by basic physics, the second law of thermodynamics. There are no mechanisms to support EM radiation action. Well, there is one that is very prominent. It is not the only one. I'm sure there are many others, but oxidative phosphorylation is used in all living systems to sustain the currents of electrons and protons that maintain levels of ATP in mitochondria. So this is maintained by a movement of electrons and protons. So if you are alive and you generate ATP, you have electrons and protons that are continuously moving inside you. So if they had gone a little further than 1899 in their thinking, and you remember that these companies always assure us they're keeping abreast of the science to protect us, that they're very, very, very carefully assessing things. If they had looked at the Bennett-Chandler equation, they would have seen in this equation that quantifies the energy of activation of chemical reaction, that there's a term here that includes entropy. And what entropy brings us to is to the fact that any living system has to generate free electrons and protons. And we will see how that works in the next slides. So the second law of thermodynamics, this is one of the most serious principles in physics. It says that the entropy always increases. So if you have a self-organizing system, like I've illustrated this here, you see the organization of the nose of a C. elegans and the organization of DNA. These organizations require that the system generate disorganization elsewhere. And we see that in biology as metabolism. You have to act if you are alive. So this law of thermodynamics requires the transfers of electrons from oxidized atoms to those that are reduced. And this is what we do with food. Food allows the transfer of electrons that power our ability to metabolize. So this is a very, very old, very old, it's a very well-established chemiosmotic theory. Oxidative phosphorylation is the subject of many Nobel Prizes, and it is completely accepted in biology, at least since 1978. So if they were carefully monitoring the science, they would have known that they had to take that into account. So oxidative phosphorylation is something that happens in the mitochondria of your cells. Some of your cells, like the cell of your heart, can have as many as 50,000 mitochondria. And inside each of these mitochondria, you have these circuits of protons, illustrated here, and of electrons, which is the black line, that must flow continuously for your cell to continue to be alive. And this is basically the ionization ingredient in the interaction between fields and health. So reactive oxygen species and redox reactions are more or less the same thing. But in the case of oxidative phosphorylation, the way we oxidize food stretches the paths of protons and electrons to lengths of 100 to 200 nanometers. These paths of electrons and protons are antennas that can be disturbed by external electromagnetic radiation. And if you want to know what happens when you stop these currents flowing, well, I have an experiment here that is very simple. I am examining the electrical impedance of the brain of a rabbit. And all of a sudden, I inject some phenobarbital into an artery, and the rabbit dies. And you can see here the very rapid changes in impedance of the tissue due to the disappearance of the electrons and proton flows that also eliminate the ATP. So those are scientific measurements that monitor directly the cessation of these flows of electrons and protons. So if you look at the human body in its completeness, well, there's many cells in the human body. There's many mitochondria per cell. Here I have an average of 100, but in fact it varies from cell to cell. And there's many ATP synthase molecules per mitochondrion. So there's this number of conductive paths in your body. And this number is in the numbers of sextillions of conductive paths in your body. So in fact, you are an antenna, an electrical conductor. And this is an obligation due to the fact that you metabolize stemming from the second law of thermodynamics. So it's undeniable that all humans are extremely conductive material. So if you are extremely conductive material, you're also an antenna, and it is unavoidable. This is the principle of superposition. If you apply another field to currents that are already flowing, whatever their intensity, whatever the intensity of the field, there will be an addition, there will be a perturbation of the currents within your body by the currents, by the fields that are externally applied. So using three well-established components of science, the second law of thermodynamics, the anatomy of oxidative phosphorylation from biology, and Maxwell's equations, we can demonstrate that health impacts of non-ionizing, non-thermal electromagnetic radiation are inevitable. In metallic antennas at room temperature, an antenna used by engineers is at room temperature, but the electrons sense tiny signals in spite of the fact that they are at room temperature. And as electromagnetic fields penetrate tissues, they influence the motion of the sextillions of free electrons and proton circuits within the body. This is inescapable. So the arguments of industry, it's non-ionizing, it's non-thermal, there's no mechanism, are entirely bogus. And it's extremely surprising to me that they were able to continue them for this amount of time. So these three arguments have misled industry itself, toxicologists, public health, and epidemiologists for decades. It's not easy to do. Although epidemiologists clad themselves with the objectivity of statistics, many of them are nonetheless heavily influenced by physics, simply summarized as absence of mechanism. In physics, we study things that are relatively unchanging, like the speed of light, the direction of time, from the second law of thermodynamics, the conservation of energy. So people respect these things a lot. So when you're a biologist or an epidemiologist or a physiologist, when somebody from physics tells you things are impossible, you tend to withdraw. This is what happened. So narrow-minded physics formalism coordinated with an exclusion of biology and physiology, were used by industry to discredit perfectly valid observations in laboratories and populations. Research opportunities on health impacts of EMR were closed as scientific and public opinions were manipulated to protect commercial interests. So the last thing is an exam for you. I want to know who's responsible for all this. So who is to blame for the poor assessment of the risks of electromagnetic radiation? Is it the power industry? Is it the wireless industry? Is it the physicists, the physiologists? We did not challenge the physicists, the biologists, the public health people, the epidemiologists? Is it the Institute of Electrical and Electronics Engineers? The International Commission on Non-Ionizing Radiation Protection? Is it the World Health Organization and Bill Gates? Is it academic institutions? Is it government officials? Is it professional bodies? Please tell me. Thank you very much.
Thank you, Dr. Héroux, for clearly illustrating that the health effects of non-thermal, non-ionizing radiation are fully supported by physics and biology. The electron and proton currents are central to life. You clearly illustrated that non-ionizing radiation can disrupt gentle cellular processes, including ATP production in mitochondria, by influencing ions and free electrons in our body. The metabolism of living tissues relies on delicate electric currents within cells, and disruptions to these currents can lead to the formation of free radicals, key contributors to numerous diseases. Despite these risks, the health impacts of electromagnetic radiation, that's EMR, have been dismissed. Your presentation highlights how science has been compromised by poor research and industry influence. Thank you for your internationally recognized work.